Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. We are discussing welding processes, and so far we have discussed all the arc welding processes, that is fusion welding processes one by one. Today in this lecture we are going to discuss about the solid state welding and whatever the processes are there in solid state welding. First we'll see what is the meaning of solid state welding, and then whatever the processes are there which comes under this category, that is solid state welding. So one by one we'll discuss that one, and then we'll proceed further. So in today's lecture we are going to cover solid state welding. We'll see what this solid state welding means, and what are the important things in this solid state welding. Then we'll see the solid state welding processes, solid state welding processes like roll welding, explosive welding, and then friction welding. So one by one, these three processes which are a solid state welding process, we are going to discuss in detail about these processes. But first, we'll start with the solid state process. What is the meaning of this one? So, what is solid state welding process? If you remember, when we were starting this welding lecture, at the starting, we saw how to classify the welding process, or rather, how to classify the joining processes. So, we have seen welding is a permanent joining process. Joining process means permanent means if you have to dismantle the parts, whichever part you have joined together, so without physically damaging, you can't dismantle the parts. Okay. So that is known as welding, and it occurs at atomic level. Okay. So in that we classify welding processes broadly in two sections or two parts, and we saw first was actually fusion or liquid state welding. So what we saw, liquid state welding means, suppose I'm welding a solid part. Suppose this is stylus, and this is its something here has been attached here. If I have to weld these two parts, so if I'm using heat to join or pressure I'm using to join, if this solid state of the material is not changing, means it is not changing to liquid state, then we say that this is a solid state welding process. But if during the welding there is a melting over there of the material during the process or during the welding process, then it is known as liquid state welding process or fusion. So far whatever the processes we have discussed, almost all the arc welding processes, then we discuss resistance welding process, we have already seen thermite welding process, plasma arc, all this we have discussed, all were in the category of liquid state welding or fusion state welding. But today we are going to discuss, this is solid state welding, means the material that we are going to weld, it is not going to change the state from solid to any other form. That's why it is known as a solid state welding process. So that has been written. In solid state welding, joining of materials are performed with the help of heat and pressure or pressure alone. So anything can be possible, means during the welding we need to apply heat, or maybe heat is not required, only because of pressure we can do the welding, just like in a roll welding. We'll see once it will come. There you can apply the heat, or you are also free not to apply the heat depending upon the situation. So if you are applying the heat, then also they will be welding. If you are not applying the heat, then also they will be welding, only because of the pressure. Okay, now. So that's why it has been given here, or it is written that the solid state welding is possible either by heat and pressure combined also, or only heat or only pressure. We can weld the material together. So what actually happens in this one? What is the meaning of this one? As I said, material is not going to change its state. It will remain in solid state. So a metallurgical bond is created with little or no melting of the base metals. There will be no melting of the base metal. Okay, now. So to metallurgically bond two similar or dissimilar metal, the two metals must be brought into intimate contact so that their atomic forces attract each other. This is very important. If you are not using heat, and only through pressure you are joining two parts, very important to understand, the two parts that you are going to weld together, that should be very close to each other. Okay, now there should be a proper contact between, and whatever the contaminations are there on the surface, that need to be removed, so that those two parts that we are going to weld together, that will have actually intimate contact, so that atomic forces, that attractive atomic forces will come into picture, and two parts will be welded together. This is very, very important to understand. The two surfaces must be clean. Yes, these two surfaces must be clean, which we are going to weld together. And what are the things that may be on the surface? Oil may be on the surface, dirt may be on the surface, chemical films may be on the surface, or any kind of gases may be on the surface. So what we have to do before starting the welding, first we need to clean the surface properly. Okay, different methods are there, different solution we can use to this one, or ultrasonic cleaning is also there. So that also we can use to clean the surface. Okay, depending upon the material, different techniques or methods are there, through that we can clean the surface of the material. Okay, so once it will be cleaned, then these two pieces will do the welding. Whether we are doing different solid state welding processes are there, but first we have to clean the surface, and then we'll have to subsequently go for whatever the welding processes we are going to use to join these two processes. Some of the solid state welding processes are applicable to join. Yes, this is the most important property of this process, that this can be used for joining of dissimilar material. It's very difficult to weld if two materials are having different nature. It is very difficult to weld. What is the reason behind? Many reasons are there. Their physical property may be different. Physical property means, for example, if melting temperature of two materials are different, it is very difficult to weld. If mechanical property is different, that is also very difficult to weld. For example, suppose I am taking one piece, this one piece and this another piece I have to weld together. Okay. So if this is a one type of material, suppose P1 this material is, and this is a P2 material, and both are having different nature. Suppose their physical property is different. This is having a melting temperature of, for example, T1, and this is having melting temperature of T2. Then if we are using a welding process to join these two processes, then what will be the heat? How much heat we are going to provide to melt the material? It will be very difficult. And which area we are going to put the heat, that is also going to be very difficult. So if I am going to weld in this section, it will create a lot of problem, because both are having different melting temperature, and I know to weld these two, I need to melt the material wherever they are in contact. Then and only then there will be welding. So if different melting temperature of the materials are, it is very difficult to weld. So that's how, if this kind of weldings are there, then in solid state welding it becomes very easy to weld. So that's what has been given here, that applicable to join dissimilar metals without concern about their relative thermal expansion, conductivities, and other problems that usually arise when dissimilar metals are melted and then solidified during the fusion welding. Yes, this is the most important property of this process. What this even is, means whatever the problems were there during the fusion welding, that different thermal conductivity will create problem, different melting temperature will create problem. Not only that, once it is melted and after that it will solidify, then a lot of problems will come into picture, like residual stresses will be there, thermal cracks will be there, many things will be there. So all those things easily can be eliminated in this process. That is the reason this is a very, very important process of welding. Okay, and that is the reason this process is generally used for light metals, which are very difficult to weld. Light metal means, for example, aluminum. If I have to weld, if it's I know we know thermal conductivity of aluminum is very high. So if this is the one piece of aluminum and this is the another piece of aluminum, and if I have to weld these two parts together, and this is the area I have to join, if I will put heat in this area, because of the high thermal conductivity, what will happen? Heat will be dissipated with very high rate, and because of that I will not be able to concentrate the amount of heat needed to melt the part at this section. So it will create problem. If I will increase the parameter, suppose I'm increasing the current, so heat input of course will increase, but what will happen? That heat will also be dissipated in this area. So not only this part where we are doing the welding, the other parts of the parent metal will also be, most of the part will be affected by the heat. And if it will be affected by the heat, we know there will be coarse grain in those area, and finally their mechanical property is going to be reduced. So this is not the case in solid state welding process. That is the beauty of this process. So first, this solid state welding that we are going to take is a roll welding, or this is also known as a roll bonding. So what happens in this one? Two or more sheets are kept one on the another, and they are rolled together. Okay, with heat or without heat. Depending upon that, it is having two types. If we are not using heat, it is known as cold roll bonding. If we are using heat, it is known as hot roll bonding. So depend what will happen. Basic requirement we have to keep in our mind. What was the basic requirement for the solid state welding? The two surfaces or two sheets that we are going to weld together. Suppose this is the one sheet and this is the another sheet. We'll have to keep in mind before starting the welding, we have to clean these two properly so that anything, any kind of contamination, if it is there on the surface, that should be completely removed. And once it is completely removed, after that, what we'll do, these two rollers will bring these two parts towards inside this one, and these two rollers are there generally made up of high carbon steels. They are capable of rotating on its axis. So this is the axis on which it is rotating, and this is the axis on which it is rotating, just like rolling. So what will happen once this workpiece will come inside, because of the compressive forces from the both sides, these two parts will be welded together. And once it will pass, you can see here it is moving this just like a rolling seat, and it will be once it will pass, pressure will be from both sides. It will be welded over there. So in this roll bonding, both things are possible. So once we defined at the starting the solid state welding, this material we can use pressure, or we that is optional. Not optional means in some of the processes pressure will be used, some of the processes heat will be used, and in some of the processes both will be used. But here we can see only pressure is sufficient to join these two parts together, because once these two parts will be in intimate contact, so their atomic forces will come into picture and two parts will be joined together. So in this, heat may be used, heat may not be used, but pressure is necessary to join two parts together. So if heat is using, then it is known as hot roll bonding. If it is not using, it is known as cold roll bonding. Next is explosive welding. Here also there will be reaction. Explosive welding means these are the two plates. Suppose this is the one plate which is at the top, and this is the another plate which is at the bottom. So technical names are there. The plate which is at the top, it is known as flare plate. The name is flare because it will come and strike the bottom plate. That's why its name is flare plate. And the gap between these two is known as a stand of distance. This is known as a stand of distance. A stand of distance. And on the first plate here, a buffer zone is provided. Buffer zone generally or rubber is being provided. So during striking, if stress will be generated or vibration will be generated, it will be able to absorb that one. So this is also provided. And here explosive is there. You can see here explosive is there. It is completely filled with the explosive on the flare plate, and you have a detonator. Here the detonator is okay. We can ignite this one. So this distance is there. This is the clearance or extent of distance, and at the bottom there is the anvil which is fixed. Actually, this is the anvil which is fixed. On this we have kept the plate, the first plate, which is known as actually backing plate or backer plate. Here backer plate, and this is the flare plate. On top of that we have a explosive with a detonator. So what will happen once we'll detonate this one, this will with a high velocity it will come down and it will strike this plate, and once it will strike, you can see here there will be joining between the parts. How it is looking like at an angle, because this detonation it will propagate from this direction. So at which it will propagate, it will strike and then strike and then strike. So at this is actually, if this explosive is detonated, so slowly it will move, and as it will move, it will create an angle like this. But finally, once it will reach here and it will be completely exploded, so this part also will be in contact with this one, and finally this will be joined like this. So it will look like this. Suppose this is this one, and this part it is looking at the angle, but finally after joining it will look like this. Okay, but as this explosion is progressive from this end to that end, so as it is moving, the part which is actually being joined is looking like this, and the other part which, or the detonator which is not detonated or not exploded, so that's why this plate is looking like. But once it will be detonated and once it will be exploded over there, this part will also come and strike at this section and it will be joined over there. So it is very very important to understand what will happen once it will striking. It is striking at a very high velocity. So what will happen? The part which can be welded, it will be like this one. So a zigzag surface will be created between these two welded sections. So this is also explosive welding. Here also there will be no melting the material. One plate we are joining with this another plate. These two parts, there will be no melting over there. What actually is happening because of this explosive, this first plate with, sorry, the flat plate is having very high velocity. With that high velocity, high pressure, it is coming and striking on the second plate where we have to do the welding, and because of the atomic actually joining, it will join together. So nothing is happening here if parts are not being melted. That's why it is a solid state welding. The only one drawback with this process is the surface generated will be rough wherever we are joining, because of the high velocity it is going and striking over there. Okay, so what is the explosive welding? Because of the progressive explosion, that's what I told, progressive explosion, high pressure zone propels the flare plate to collide with the backer metal progressively at high velocity, so that an angular shape is, as it is progressively moving from one end to another, that's why angular shape is created. This is the angular shape is created. You can see if you're writing this theta, so this angular shape will be created, but it takes very less time. Okay, na? So immediately it will be joined this one. Advantage generated as a explosion advantage. Next is a friction welding. Friction welding means the welding, as the name suggests, will be because of the friction. Here both things will be there. Heat will be there as well as pressure will be there. So what actually happens? What is the drawback of this process? We are starting with the drawback. Drawback in this process is only a part which is having actually axial symmetry can be welded by this one, just like a cylinder. You can see here. This is one of the pipe and this is another pipe, a cylindrical shape. If it is not having this kind of shape, it will not be welded by this process. This is the drawback of this process. So how it actually works, this is the one part which is actually fixed. And suppose this is the another part which is movable, means it can rotate on its axis. So this part is fixed. Sorry, here it has been shown this part can rotate and this part is fixed on here. So what will happen in first part? This is the pipe we have to weld with this one. So one pipe is kept fixed and another is capable of rotating on its axis. In second step, you can see these two parts we have brought together. So what is happening? This is fixed, but this is rotating. So what is happening at this section where there is contact, there is relative motion, and whenever there is relative motion between the two parts, we know there will be friction, and because of that friction, what will happen? Heat will be produced. So that heat produced in that area will start to actually increase the temperature of the part which are in contact, and once it will go beyond its recrystallization temperature, means once the temperature will be sufficient, what we will do from both sides, we'll apply the force. Here it is. So from both sides we'll apply the force. So what will happen? Both part will actually joined at this section. Finally, you can see this part has been joined together. A little bit of flash will come out on the surface that after joining will trim and take it out. So what is happening? Stepwise we have seen. What is the important thing here? As the two plates, sorry, two pipes or the two sections that we are going to weld together, we are keeping one at rest, means one we are keeping fixed and another one is free to rotate on its axis. So what will happen once it will rotate on its axis, and when these two parts will be in contact, one is rotating with respect to the other. So what is happening? There is relative motion between these two parts, and because of the relative motion, we know there will be friction because both are solid. So what will, because of this friction, heat will be generated in those areas, and that heat with the speed, it depends on many parameters. Okay, now so once this that heat will reach will go beyond the recrystallization of the material. Material will start to flow over there. Flow means it will be in plastic state, and once it will reach over there, then we'll apply pressure from both sides, and they will be joining at this section. So finally you can see, and what will happen because of this force as material is flowing. So what will happen, the part where we are doing the welding, a little bit of material will come out in the form of flash on the surface that will trim and take it out. So finally these two parts will be joined together. Here also no need to tell, there is no melting of the material. So this process also comes under solid state joining process. So that's all for today. We'll stop here, and the next, no, lecture we'll see. Only three things are left in this series, in this welding processes. Soldering and brazing. Two special welding processes are there. So in next lecture we'll see what is soldering, what is brazing, why soldering and brazing required, and where it will be, where these two processes are being actually used. And of course we'll see what are the defects if you are doing the welding. So what are the defects there in the welding and what are their remedies? So one by one we'll see that one in next lecture. So today we're stopping here. Thank you.